My goal for today's video is to be able to explain how to build a complete production-ready app from scratch as simply as I can. So the topics we're going to cover today are planning, which in my opinion doesn't get covered enough, and I think it's one of the most important parts of building any software. Some other steps you should take before you start building an app. Building the actual app, then there's 3 types of testing that we're going to cover, and finally maintainability. And hopefully by the end of this video, you'll be able to be confident about the apps that you're releasing to all the app stores. And let's get into the video. Okay, so today the app we're building is going to be a very simple to-do app. Now the code for this app isn't going to be too complex, but we're going to focus on the process and make sure we go through all the steps necessary to be confident about launching our application. And to start with that is planning. I think planning is the most overlooked topic when it comes to creating any type of software, especially creating an app. We're going to focus on the 2 main parts of planning today. One of them is requirements, and then design. So what are requirements? It basically breaks down the big requirement of build a to-do app into smaller sections that are more achievable and that you can test at the end. So we're going to have requirements like the following. We're going to have create account, be able to log in, be able to sign up, only display not finished to-dos, keep the list synced up with Firebase. Last 3, if no to-dos, say that there's no unfinished to-dos, be able to add a to-do, and check off to-dos. Now for each of the topics we're going to get in today, there's whole methodologies about how to do them. And just like, for example, requirements, there's ways to actually structure the sentences in a way using words like shall and must. But today we're going to keep it simple. If you're interested in any of these, make sure to do more research. We just can't cover it within like a couple hours. So we got 8 requirements for this app. Now let's get into the design a little bit. So with design, I like to use Adobe XD. And there's other options like that you can use. But for this one, we're just going to do some very basic draw-ups. So we'll have the login screen, and then we'll have a logged in screen. So here we're going to have a field for the email, the password, and then a login button, and then a register button. Nothing too complicated. Then once inside, we'll have an app bar with a sign out, and then add to do. And then down here, just a list of to-dos. You want to kind of gain a vision for how the app's going to work and make sure all the parts are thought out. For example, if we didn't think about the sign out button at the top and we wanted to put something else at the top, it gets a little cluttered up there. You just want to think about it. Now the design doesn't only include how the app looks. There's also the architectural design of it. So for this app, it's pretty simple. We're gonna have the main, which will check for authentication. And this is not a widget, this is just a check. Then if the authentication data hasn't been received, we're gonna show a loading screen. If there's an error, we're gonna show an error screen. If there's no user logged in, we're gonna take them to the login screen. And then finally, if they are logged in, we're going to take them to the home screen. Now, inside these 2, inside the login screen, we'll have a username widget, a password widget, and then 2 buttons. Then on the home screen, we're going to have a sign out button, an add to do widget, and then a list of the to-dos. So this is pretty much the widget tree. There's software like Draw.io that you can use, but this works for us. So that's all the planning we're going to do for this specific app, but a more complex app should have days or even weeks of planning, in my opinion. The things you need to think about are object-oriented principles and stuff like that. You could look up the principles called solid and grasp. Those will help you separate the widgets out and keep your architecture clean. Alright, and next is to create some sort of version control and some way to be organized. I think almost everybody uses GitHub nowadays, so make sure you create a GitHub project and create some tickets and issues in there that you want to work on, things like that. And then finally, we can start on the code. So I'll go do that right now. I'll set up a new Flutter project and a new Firebase project and connect to it. Okay, so we got our Firebase project with the email and password sign-in method enabled. We're able to run our app once to make sure it works. So then I imported these 3 packages so we could use everything we need with Firebase, and then also lint along with analysis options.yaml, so we can have a static analysis tool that tells us where we can improve our app performance. So here you see problems with const. We could add that before. And now our app will technically be a little bit faster. Now we got a little bit more preparation before we're ready to start. We need to set up our folder structure. Folder structure is very important to make sure you have everything organized and you can access it real quickly. So this is the one I use, but every project should be a little bit different depending on what it needs. So I have a screens folder, a models folder, a services folder, and a global widgets folder, or we'll just call it widgets. So models are like bits of data that go together. For us, we're going to use a to-do model, which will basically consist of data that is included within every to-do. Then we have screens. We're going to have the login screen and the home screen. Services, we're going to have 2 services, authentication and the database service. And then we have global widgets. We're only going to have one in there called a to-do card, which basically will make all our to-dos look the same. So now are we ready to start? Not yet. There's still some more decisions to make. Now the final decisions you should think about before starting your app, whether you want to do TDD, which is test-driven development. This is actually a really great way to write apps, but I personally don't like it too much because I find it a little bit boring. I like to write a little bit of code and then write the test for it right after. Then there's the state management decisions. For us, we're not going to use any state management solutions other than set state because it's such a simple app. But state management is a huge topic and will definitely clean up your app architecture a lot. So definitely take a look at it. The top 3 are provider, get, X, and block. So you could take a look at each of those and see which one you prefer. And now finally, I think we're ready to get started. So one thing to keep in mind when you're building an app, keep things simple and keep them iterative. So that means do one small part at a time, make sure you check all of it, everything works, and test it, all those things. So the first part we're going to start with is getting our connection to Firebase working. So this part's actually pretty simple. There's a new firebase.flutter.dev website that kind of helps you out. And this is the initialization code that we're just going to copy and paste right in here. So the code in here runs the app. You first initialize the app and return a future builder, which depends on that initialization. So this future builder pretty much takes in a future and builds depending on what state that future is in. So if the future has an error, we're going to return a scaffold with a center child text error. Very simple. And then you see the blue, that's our linter popping up saying we need to fix that. Then if our connection is done, that means it was successful and you can go to your app. We're not going to touch that yet. And then the last case is it's still loading, that if it doesn't have an error and it's not done yet, then you know the only option left is it's loading. We're going to return the same thing except we're going to say loading. Now the most important part, if the connection is done and secure, we're ready to move on to our app. Also, one thing to keep in mind, we're going to go through this code a little bit fast because there's a good amount of code in there, but we want to mainly focus on the testing aspect of it. But I still want to go through the code a little bit so you kind of get like a thought process of how you think through building an app. So we have our Firebase connected. Now there's another precondition we need to check, whether the user is authenticated or not. So we're going to do it inside a root widget, which is going to be stateful. So you can put this in another file, but for simplicity, I just put it in here. And this is going to send us to our root. So root is going to decide where the next page is. So now inside our root widget, we're going to create our Firebase auth instance. Firebase auth. We'll call it auth, and then Firebase auth.instance. And then while we're here, might as well create a Firestore one. Firebase Firestore. So then we get into the actual return type. I like to use a stream builder for the authentication because anytime anything changes with your authentication state, it'll be updated because it's being streamed. So the way we do this is we need to give it a stream, and our stream is actually not defined here. So we're going to have an auth stream. So remember I told you there was going to be two services that we have. One for connecting to the database, which is Firestore, and then one for the authentication. So let's do the authentication part. We'll have a file called auth.dart, and in here we'll have a class called auth. We're going to need to pass in a Firebase auth instance, and thus create a constructor for it. And we're going to have three functions in here. One's going to be a stream of type user, which is a type returned from Firebase. And we're going to get that from auth state changes. So anytime the state changes, we'll get returned a user and all the data for it. So just like that. Then we'll have three other functions. One's going to be called create account, where we're going to need to pass in an email and a password. Anything that's related to the future, I always make sure to wrap in a try and catch, because if anything goes wrong, then it gets caught here. Here we're not going to actually do anything, we're just going to rethrow it back, but if you want to create any actions based off of a problem occurring, like maybe a snack bar, you want to make sure you return whatever you want to return. Then inside this try catch, we're going to have create user with email and password. Really simple, pass in the email, password, and we're actually going to do email.trim just in case they put a space after it. Then if that's successful, we're going to return success. And now the reason I made a return a string is because we're going to also do an on Firebase auth exception. Now we're going to catch that as well and return e.message for that. So basically, if there's an exception from Firebase auth, it catches it in this variable e and it'll return a message for you, basically why it failed. Then we can return that from this function, give a little snack bar or something telling them that it failed and why. So we're going to have two more functions, one for signing in and one for signing out. I don't think we need to go through that. They're going to be pretty much the same. All right, so that's it. That's our three functions. That's all we're going to need for the authentication. Notice how clean this code is. All we're going to have to do is call this create account function, and everything's going to be handled for us. So now in the main, we finally have our auth class. And remember, we need to pass in a parameter called auth, and then the string that we're looking for is for the user stream. This error we see is because it's not a named parameter, and you just do that by adding in brackets to make sure it's named. I like to make sure everything's named for myself. So we have our stream defined. Now the builder. Notice everything's filled out for us. We have our context and a snapshot of our current user. If our snapshot connection state is equal to connection.active, which means our authentication stream is active basically, Otherwise, we want to return another loading state, just like that. Now, if it is active, we have a couple more conditions to check. So snapshot.data, and we can look for the UID. If the UID is null, then we know there's nobody logged in. Otherwise, UID is not null, we'll know there's someone logged in. So these two screens are going to be real simple, so I'll make those real quick and be right back. Alright, so both of those are done. They're both very simple. The login screen has 2 text form fields and 2 raised buttons that don't do anything just now. And the home screen just has an app bar. So here, if it's null, return login with an authentication of auth and a Firestore of Firestore. Now we're doing a lot of passing authentication and Firestore everywhere. This is why I think you should use some sort of state management, because you won't need to pass those around everywhere, but it's not too bad for us. Then over here, we're going to return the home screen. And we're going to need an auth of auth again. And Firestore of Firestore. Now within the to-do widget, we have the 2 functions for signing in and creating an account. All we do here is call those functions we created. So this will return a success or the error message if you remember. We're going to need to do auth and sign in the user with email from the email controller and password from the password controller .text. Then we can check if the return value is equal to success. Then we can clear those controllers. Otherwise, let's display a snack bar with the return value, because remember, we'll return the error. Okay. Copy paste that and add it here. Obviously, it'd be nice to have another function like this, but I think since it's such a small piece of code, it's okay, and we only do it twice, so not too bad. Login screen should be done. And I think we can run the app at this point and see if it works or not. And of course, things can't work on the first try like that. But it's actually pretty simple. We never wrapped it in a material app or anything. So make sure this future builder is wrapped in a material app. And then this should be the home. And we might as well add some theme and make it dark theme, because, you know, we're programmers. That's kind of what we stick to. And there we go. Let's see if it's working. So we create a username. Let's just type anything. Sign in. Password is invalid, and the user does not have a password. Or the user does not have a password. Okay. So let's try tatis@gmail.com. Password 123456. Sign in. There is no user record corresponding to identifier. User may have been deleted. Okay, then let's create an account first. We created an account, and there we go. We're back in the home screen. Now, last part before we start testing is let's actually do something when we try to sign out. So here we need an auth again. We have our authentication pass to this, and we can just do sign out. Easy. And now hopefully we click it, and we'll go back to the main screen. And we're able to type in our email again. And this time we're not able to create an account. This email address is already in use, but we're able to sign in. There we go. That's our full complete login process. Now after this stage is where the testing begins. So the nice thing about test-driven development, or TDD, is that at this point you're pretty much done. You know your app is fully tested and that everything works. But for us, we don't have that yet. So we're gonna add some unit tests. So what unit tests are, they basically test the unit per se. So a unit is just a function pretty much, And the only things that really make sense to test in this application are these functions that we have. Create account, sign in, and sign out. You also want to be careful about not writing useless tests. You don't need to write a test for every little simple thing you do. In fact, there's probably an argument that these don't really need to be tested, since Firebase already tests this for you, and you're not really testing much. But just for demonstration, we're going to go through it. So the reason I wanted to go over it is because these tests could be a little bit more complicated given that they need mocks in them. So we're going to need to add some more dependencies in here. We're going to add Mockito, and then we're also going to add Flutter driver and test. But those are for the integration test. For this one, we only need Mockito and Flutter test. So each of your tests needs a main. And then inside you can have a setup and a teardown. So what these are, the setup runs before every single test and the teardown runs after every single test. Then checking back to this class, what was the one thing I said we were going to need? This Firebase auth. In order to do anything, we need this authentication. But for us, we're going to be mocking it so it's not calling the actual database. So like I said, the thing we need to mock is the authentication class. So we will create a mock auth class. The way you mock it is you need to extend that class with a mock. And you'll see we have a library imported, the Mockito library. And then it implements our Firebase auth class. So basically, this says we're mocking our Firebase auth class, and this is the class that will contain all the mocks. So once we have our class defined, we can create an instance of it, and now we will be able to use this for all our tests. So our first test, we're going to call emit occurs. So we're going to test that this auth state changes actually emits and we get a user from it. We do that by overriding the function up here. So auth state changes, you just type it out. I'll send you this whole thing. And what we'll need to use is a string.fromIterable. Now inside here, we're going to iterate over the type of objects this should use. So you saw this should return a user. So what we're going to do is create a mock user as well. So we'll have mock user extends mock implements user. And then here we can return a mock user. So before we get to the actual test case, I want to change this name to mock Firebase auth. Just to make sure we're all clear that this is the Firebase authentication. Our class is actually called mock as well. So we're not mocking this class. We're mocking the Firebase auth that we're passing in. So now we can create our instance of our auth class as well. And remember, we have to pass in an authentication. And that authentication is going to be mock Firebase auth. So there. Now we have our auth class that we can use for all our tests. So here we want to call expect later, which is for anything with futures. And we're expecting the auth user class to return a stream, which we can check by emits in order. And inside here, we'll have the mock user. So there we go. Now, if we run it, well, you'll actually see a problem. There. So we were expecting an emit of the type mock user. Instead, we got an instance of generated stream of just user. So what happened here? Well, in Flutter, if you have two instances of an object, let's say you do this simple check. If you do mock user is equal to mock user. Even though they are exactly the same, this will always return false. This is because a separate instance of mock user is not equal to a different instance. There are packages like Equatable and other ones I'm pretty sure that actually check the properties within that tell you whether they're equal or not. But since we're not using that, we have another option. You can create a variable for mock user, and then use the same instance within this iterable and this emit check. So now if we save and run, everything passes. Great, so we got the emission there. Now we go back to this function and we need to check this first part, whether create an account works. So you can copy paste that and check create account. So here the difference is we want to mock an actual call to the database. So we want to mock this create user with email and password. We're not trying to override it like we did here. We're trying to catch it and then return something of our own instead of the database. So you will need to do when, and then inside basically do when the mock Firebase auth dot create user with email and password gets called. With the fields we'll say tadas@gmail.com and password 123456. So when that happens, then answer, and we put in whatever value we want it to answer with. So actually in this case, we don't really care what it answers. It will just return success no matter what the answer is. Unless it throws an exception, that's the only way it doesn't return a success. And it will throw an exception if this wasn't successful, basically. So we mock it, we don't really care what the return is, and then we can do an expect where we await our auth class create account. And we want, if we don't pass anything, that means these aren't going to get called with the specific fields that we mentioned here. So we want to make sure we pass the email of tadas@gmail.com and password of 123456. Now since it gets called with those exact fields, it'll return with a success. Okay, let's try to run it. Perfect. It works. Now we could check the same thing except for this Firebase auth exception. Make sure the exceptions actually work. Create account exception. So when this function gets called, instead of returning null, let's actually throw a Firebase auth exception. And you can put your own message like, you screwed up. And now we can actually copy this message, and that should be our return for that function. Now we could run all three actually to check. All of them pass, perfect. Now I'm going to copy paste these, and we'll do for sign in. And we'll do sign in with email and password, pass those in, sign in. That should run. Sign in exception. We do sign in with email password. Sign in function gets called, perfect. Now we should be able to run those. That one runs. This one runs. And then we could do the same thing with sign out. These don't need any calls. Let's check how this function works. So success if it's null, and same thing with exception. Very easy. Sign out. And there we go. Now we can run all of these tests. And we have 1, 2, 3, 4, 5, 6, 7, 8 tests that all pass. Let's say Firebase gets updated or something, and the sign out function works differently. Our tests will not pass anymore. And now we have full coverage for all of our authentication functions. And let's say Firebase updates, they no longer throw a Firebase auth exception, they throw something else. Then one of our tests is going to fail when we run it, because we only catch a Firebase auth exception. We don't catch the other ones. So our code is more safe, and you'll be able to catch problems with anything you interface with, and you'll know that it's not your app that's actually broken and it's something else. So that's it. Now there's another type of testing called widget testing. Widget basically tests your UI. The thing is, we don't really have anything that's driven with the UI here. We just have a sign-in screen that is based off of the Firebase database. It's not really UI changes, right? So we'll come back to that and the integration tests after we do the to-do lists. So for this next part, we're just going to go through the database interfaces because the rest is just making UI to work with it, and I don't think that brings too much value for you guys. So we're going to need a to-do model. And here we're going to have a to-do model class with a to-do ID, the content of the to-do, and then whether it's finished or not. Then we're also going to give it a name constructor from document snapshot. And we're going to want to pass in a document snapshot for it. Then in here, just simply set the to-do ID equals document snapshot dot ID. Content equals document snapshot dot data. Content as string, and then same thing for the done, except as Boolean. Okay, so now our database class. We're gonna need to pass in Firebase Firestore and the constructor for that, and then we're gonna have a stream of the list of to-dos that we have. So stream of list of to-do model. I'm going to call that function stream to-dos. And all we need is the UID of the user. So the way our database is going to work, we're going to have a collection called to-dos, then have a document with the UID, and then within that UID we're going to have the to-dos for that specific user, and then we're going to have the to-do ID, content, and done. So that's what our database is going to look like. Very simple and easy to use. So for the stream, we want to, again, try catch as always. And we will try to return firestore.collection, remember to-dos collection, .document of the UID we passed in, and then that collection of to-dos. And we only want to get the ones where the done field is equal to false. And then we want the snapshots of that. So that returns a stream, but we want a stream of list of to-do models. So we got to map it to such a list. These snapshots will return a query for us. And then I like to space it out even more. We will have a list of to-do models that we want to return. And at the end, we got to make sure to return that. And then in here, we're going to have a for loop for each document in query.docs. So all the documents that query returns, we're going to iterate through every single one and then append to the list we have with a to-do model from document snapshot and a pass in that document. Okay, that was a mouthful, but it's not as bad as it looks. So we return a query, and then we go through every document in that query, add it to this list, then return that list through a stream. That's pretty much it. So then we have two more functions. I'm just going to go over them with you. There's not too much to them. This one's to add a to-do. If you remember, we need the ID and what the content of it is. So we'll find the collection named to-dos, go to that specific UID, go to the collection called to-dos again, and add a document with the content, and the done field is false. Then we want to update that to-do. So we'll have the UID and then the to-do ID, so we're able to get to the specific to-do item. And we just update the done to true. So I'll go ahead and make the UI use this, and then I'll be right back. Okay, so here we have the home screen. we have list app. We can call it amateur coder to do instead. Nice. So we have our sign out at the top. We have a text saying add to do here, a text form field, an icon button which calls our add to do function that we created, and then a list of your to-dos inside of a stream builder which takes in the stream to-dos that we created. And then similar to when we log in, we have a snapshot if it's active, and our data is empty, means we don't have any to-dos. We want to return you don't have any unfinished to-dos. And if we do, we have a list view builder which returns a list of to-do cards. And to-do cards are just a card with an expanded text and a checkbox next to it. And if we click on the check inside the checkbox, it will update our to-do to be checked. So let's see if it works for the fun of it. Go eat a hot dog. We can add that. Go eat a hot dog. Perfect. If we refresh here, showed up, UID, and a to-do, and here we go. And the cool thing is, if we update here, you'll see it update right there right away. And same thing, we got a checkbox, we click it, it's gone from here, that's turned to true, and you're good to go. If you want to implement another screen saying to-dos that were finished, you can take this code and do it. It's in the description. But now to test it. So remember the fact that I told you about there's no need to have useless tests. All these things in Firestore are already tested. So writing tests for these doesn't give us much value, actually. So we're going to skip the unit test for this. If you want to do it, it's very similar to the way we did the authentication tests. So you can try that on your own. So the thing with Flutter is there's two more different types of tests. There's widget tests and then there's integration tests. Now what widget tests are is they test how your UI reacts if you click or touch something. So basically it's UI tests. The thing about our app that we created is there's nothing driven by the actual UI. Everything is streamed. So when you click this button, you're not doing anything within the page. You're actually just sending it to Firestore, and then unrelatedly, the stream builder updates once the Firestore data comes in. So there's nothing really to widget test here, but I still wanted to show you how widget tests work, and I have a to-do app that doesn't use a database. So let's look into that. Okay, so this is the to-do app. It looks pretty similar, right? Except there's one big difference. We have a controller, and this list isn't being streamed from Firebase or anything. It's just a static list that we're holding in the app. As well, the database isn't actually a database. It's just a future that returns from database and true. So if we look at the app, you can add things like hello, add it, and then load to do from database. You load it in from database and it's checked. But if we reload it, it's all gone. Anyways, this means it's UI driven now. This button, when we click it, actually does something within our app. Before, the button click sends it to the server and then comes back, right? So here we have some widget tests. We're just going to go over them because I think widget tests have a lot of material online. I think integration and unit tests are the ones that are a little bit less covered. And if you want more information about widget tests, unit tests, and integration tests, I have videos more dedicated to that topic on my channel. So make sure to check those out. But we're going to read through this simple widget test that I have. So this test is called add a to-do and remove it. And you'll see we have this tester.pump widget. So this pump widget basically means in its RAM or in its memory, it brings that widget up in the background. Like we don't need to be running this, and this test will work. So in the background, it launches this widget. We wrap it in a material app because you need a material app to launch anything, or at least use the scaffold. Then we launch our home screen. Then we have these add field and add button. They have a value key on them. So if you go back to our home screen, you can add things called keys to the buttons and form fields, and that makes it a lot easier to find them with our widget test. You can also do find by type, what type of widget it is, by tooltip, things like that. There's more than just that way to find stuff. And then we also will have find.text get groceries. So this basically looks through everything in the widget tree and see if there's a text called get groceries. So now for the actual widget tests, we use the widget tester, the same one we use to pump the home widget. So we bring the widget basically onto the screen. We enter the text get groceries into the add field. We tap the add button, and then we call this pump function, which rebuilds just basically like set state does. And then we can expect to find a get groceries. So message finder basically tries to find a text called get groceries, and we tell it that it should only find one of them. So we can run this now, and it passes. Let's say we do finds nothing. It doesn't find any widgets. So basically we add a text field and we're expecting it not to show up. We have a problem right there. It said it actually did find that. So that's all we're going to cover for widget tests. There's a lot more documentation on the Flutter docs. You can come to my channel, check out the videos if you need some more help. But it's not too complex. The most complex one, in my opinion, is the integration testing. Okay, so we covered unit tests, which go over the function. Then we covered widget tests, which goes over a whole widget. And now the last one is integration tests, and that goes over the app as a whole. But to do that, you need to run the app. There's no way you can really test the app as a whole without running it. If you remember, we added this Flutter driver. So this Flutter driver is the one that pretty much does the driving of the integration tests. So what we're going to do is add another folder called test_driver. And here we're going to need two files. We're going to need an app.dart, and we're going to need a app_test.dart. Inside the app.dart, we're just going to copy the Flutter documentation, and this basically runs the main of our app. Call the main function of the app, or call run app with any widget you are interested in testing. So then for the actual app test, we're going to go to the documentation again and copy the code that they have. Okay, now let's read through this. So this imports the Flutter driver API. All good. We have all the finders that we have, just like we checked in the widget test, except there's a by value key, so it's a little different syntax, but similar idea. Then in the setup, we want to connect to the Flutter driver and then close it whenever we tear down. And then they have two tests here. We can remove these tests. We don't need them. Our first test will be create account. We're actually going to have 3 tests total, so we can just put them in here already. We'll have a create account, we'll have a login, and then we'll have add a to do. So notice we're doing creating the account. That means it has to call the Firebase server, right? And that's perfectly fine. With integration tests, you can do that. It actually builds the whole app with the Firebase connected to it, and you can actually run the tests. But I would recommend doing this not on the production server and have a different Firebase project that you connect when you do testing. So what I'm going to do right now is I'm going to go through the whole app and add a bunch of these value keys because we need to use them. So on the login, we have the value key called username, and we can make it constant. And I'll be back when I do this with every widget that we're going to need to use. Okay, so these are all the objects that we're going to be using in our integration test. We have the username, password, sign in, create account, sign out button, add field, add button. So now in the create account, first I want to check if there is a sign out button present. Because this builds the app and launches it. If our authentication is already there, we're going to be already logged in. This test is going to fail because we're already logged in with an account. So there's this function I made called isPresent. Basically, it looks for the value key and it waits for a certain timeout that we pass in, which 1 second. If it doesn't find it within 1 second, it'll throw an exception. We return false. If it does find it within 1 second, it will continue and we will say that it is present. So pretty simple. So we check if our sign out button is present. Then we want to await driver, which is what drives the actual test. And we want to tap on the sign out button. So we'll check if it's there. If it is, sign out. Once that's done, we're going to await driver. Like I said, this thing basically does everything for you within the app. You want to first tap on the username field. Just like you would use the app, you got to tap there first in order to type, right? And we can copy it and enter text. And here we'll enter, let's say, tadas1@gmail.com. Tadas@gmail is already taken, so we'd get an error in this case. Obviously, I don't know if this create an account test is worth making, since this is testing whether Firebase works or not, but we're just doing it for demonstration purposes. Hopefully you will learn something. So then let's tap the password field, enter the password, very secure, 123456, and then we finally tap the create account button. So that should have done the test for us. Now what do we do next? We just wait for find the text called your to-dos. If you remember on the home screen, there was add a to-do and then there was your to-do. So we find the text, we know this worked. And now this integration test is done and we can run it. So the way you run the test is you do Flutter, drive, target, and you put the test driver app.dart that we made over here as the target. So this will enable the Flutter driver extension, then run your app, and then run your tests. So if we click it, let's see what happens. So I was in the wrong directory, but then I got to the right one, and here's us running the Flutter driver. And then there's multiple devices found. I have an iPhone connected, an iPad, and then this is the iPhone 11 Pro. So we want 2. So there we go, it's done. And then now it's launching. It'll start off logged in, I think. It's logged in, logged out. You saw that got pressed, and everything worked. All your tests passed. And now if we check Firebase, tadas1@gmail.com. So there we go. That's how integration tests work. Now let's quickly add these last two. We'll pretty much copy this one. If it's present, sign out. If it's not, enter the password, and then instead of create account button, just do sign in button. Then add a to-do. We want to check if it is signed in already, just because we don't want to be doing to-dos while we're in the login screen. If it is, tap the add field, which is this part. Enter the text. Make a video for FreeCodeCamp. Then tap the add button. And then let's wait for the text. Make a video for FreeCodeCamp to show up. Also, you can add your own timeout in here if you want. Let's say 3 seconds. Make that constant again. And now let's remove this tadas1 at Gmail. So we get that problem again. And we can run our integration test again. It's running, you see logged in, logged out, logged back in, and then created a to-do for make a video for FreeCodeCamp. Nice, that was pretty cool. I wish you could slow it down a bit. So there we go. We have created a pretty robust to-do list app. It has unit tests, it has integration tests, doesn't have any widget tests, but if there was anything UI driven, would have definitely done it. There's also one more type of testing called functional testing. This is pretty manual, so I didn't really go over that, but you also want to make sure you play around with your app by yourself. Make sure the UI looks good. Like for example, all our tests would have still passed if this to-do screen right here, if this to-do was off the screen, it would have still worked because it's technically within the widget. So you want to make sure everything looks good as well. And the animations behave as you want, things like that. Now the last point I wanted to go over was maintainability. Things you should keep in mind as you work on this project, because I'm sure you made a to-do app. There's a lot of updates I want to push to this, right, to make it even better. So one great thing for maintainability is to set up a CI/CD pipeline. CI/CD stands for continuous integration and continuous deployment or delivery. I don't know, I've seen both. Basically, this gives you the ability to set up a pipeline where you push your changes to the master, and then it runs a test for you, it builds the code, it checks everything, and deploys to the App Store all automatically. I think it's very useful and makes it more reliable that like your release will happen the same exact way every time. I have a video about this on my channel if you want to check it out. It's for Code Magic with Flutter. It seems to be the go-to CI/CD platform for Flutter. Another big thing is to make sure you keep up with your tests as you go, because I know even if you do it at the beginning, it's hard to always keep up with them. But they will definitely save you time in the future. When you have updates, make sure you break it down in GitHub, keep it organized. Make sure you break it down into simple tasks because you want to make sure you incrementally change and everything works incrementally. This way you can track where things go wrong and make sure they don't go wrong, I guess, in the first place. And then as you keep building up to it, if you keep your architecture principles in check and keep your testing up to date, you'll be a lot more confident about your app and you'll be able to release the App Store with less bugs and people will enjoy the user experience a lot more. And as you go forward, I'd make sure you go through the whole process we went through today for every change. Make sure you check the requirements, go through the design, the widget tree planning, all that stuff. It might be a little bit tedious, but for smaller changes, it shouldn't be that bad, and it'll definitely make your process a lot more smoother. So that's been it for me. This code will be in the description, and I'll also add the code for the widget testing as well. And that's it for me. Thank you for watching.